two couples bought wedding pictures from a photographer. One couple bought 8 large photos and 12 small photos for $136, and the other couple bought 6 large photos and 24 small photos for $192. Find the cost of a single large photo and of a single small photo. Well, because they ask for the cost of a single large photo and a single small photo, those are going to be equal to x and y in our let statements. So let's let the cost of a large photo be x, and let's let the cost of a small photo be y. Now we need to write two equations that model the situation, and it looks like the information is split up in the problem based on the two different couples. So let's look at each of the couples' transactions. The first couple bought 8 large photos and 12 small photos. Well, if they bought 8 large photos and a large photo is x dollars, then those 8 large photos cost them 8x dollars. Because there's 8 photos and they're x dollars each, we have to multiply. It's x dollar per photo. And then plus, they also bought 12 small photos. Well, that's going to cost them 12y, because each small photo is y dollars, and they bought 12 of them, so 12y. And in total, their 8 large photos and 12 small photos cost them $136. So that total has to be equal to 136. Let's look at the other couple. They bought 6 large photos and 24 small photos. In that case, we have 6x for 6 large photos plus 24y for the 24 small photos, and we know that that cost them $192, so this equals 192. Now, this system of equations is a little bit more difficult to solve for using substitution. All 4 of the variable terms have coefficients other than 1, and so if we want to isolate any of these variables, we're going to have to divide by the coefficient, and there's a good chance that will give us fractions, at least for some of these. So instead of using substitution, we're going to use elimination here. The easiest variable to eliminate is going to end up being y, because if you look at the coefficients on the y, we've got 12y in the first one and 24y in the second one, and 24 is a multiple of 12. So this is going to end up being the easiest variable to eliminate. If we want to eliminate the y's, and one of the coefficients is 24, we want to multiply the other equation by something so that its coefficient is negative 24. If we take both sides of the first equation and multiply by negative 2, that's going to give us what we need to cancel out the y's. Let's do the multiplication. If we distribute on the left, negative 2 times 8x is negative 16x, and then negative 2 times 12y is negative 24y. So we have negative 6x minus 24y on the left, and on the right, 136 times negative 2 is going to be negative 272. Now, if we compare this with the other equation, we've got a negative 24y and a positive 24y. And so if we add these equations together at this point, we will end up eliminating the y. I'm going to take the second equation and place it under what we just got. That's going to be 6x plus 24y equals 192. And I'm going to add these two equations together. When I do that, I have a special plus symbol that I use just to remind me that I'm adding the whole equations and not just one piece or one term. This is my own notation. This special plus sign isn't used anywhere else. It's just something for me. But let's add these two equations together. On the left side, we have negative 16x plus 6x. When we add those together, we end up with negative 10x. If we look at the y's, negative 24y and positive 24y cancel out. Those terms go away. And on the right, if we take negative 272 plus 192, we end up with negative 80. So we've got negative 10x equals negative 80. To get x alone, we divide both sides by negative 10. That leaves us with x on the left-hand side, and negative 80 divided by negative 10 gives us positive 8. So we have x equals 8. But we also have to solve for y. So what we're going to do is we're going to take this value, x equals 8, and we're going to substitute it into the other equation. We've got x equals 8. And in the other equation, if we take x and replace it with 8, that will allow us to solve for y. So we have 6x, but now that's going to be 6 times 8 plus 24y equals 192. When we multiply 6 times 8, we end up with 48. So 48 plus 24y equals 192. Now we can subtract 48 from both sides, which leaves us with 24y equals 144. And if we divide both sides by 24 to get y alone, we end up with y equals 6. So if we go back up to our let statements, the cost of a large photo was x, and that's going to end up being 8. This is measured in dollars, so a large photo is $8. The cost of a small photo was y, and that's 6, also measured in dollars, $6. So when we state our conclusion, they told us to find the cost of a single large photo and of a single small photo. We can say a large photo costs $8 and a small photo costs $6. And that is our final answer.